Here's how you can make a basket every single time. To start, let's assume there's no gravity. To calculate the height of the ball, we need to multiply the distance by the tangent of the angle at which we are shooting the ball, theta. We use tangent because tangent is the height over distance. If we multiply by the distance, we are left with only the height. But we also need to remember to add the initial height since the ball isn't being shot off the ground. Looking pretty good, but gravity exists on Earth, so let's not forget to include that in our calculation. The drop in the ball can be calculated by half the acceleration of gravity times time squared. We don't have anything for time in this problem, so let's fix that. First, the horizontal velocity of the ball is the initial velocity times cosine of theta. Since distance equals speed times time is just distance over speed. So we can use the velocity as our speed, and we know that our distance can just be represented by x. So this is our time, which we also have to square. What we just calculated is the drop of the ball as it gets farther and farther from where it's thrown. Subtract this from what we have before and we get our arc. Now, we need to solve for our initial velocity, so let's isolate that. And now we just need to plug in the variables. H represents the height of our target, in our case the basketball hoop. H naught represents the height of the ball when it is released, and theta represents the angle. We also know the acceleration of gravity. Let's say the hoop is 10 feet high, about 3.05 meters. Dino is releasing the ball at 2.2 meters. He's taking a 3, so he's about 7.62 meters from the hoop, and he's shooting at a 50-degree angle, about 0.87 radians. This means the initial velocity is 9.145 meters per second, and from this we can calculate the force. Acceleration is the velocity squared over 2 times the distance of acceleration. We know velocity, and the distance of acceleration is how far Dino extends his arms to shoot, about half a meter. The mass of a basketball is around 0.625 kilograms, so the force is about 52.3 kilograms times meters over seconds squared, which we know is just 52.3 newtons. So if Dino shoots with a force of 52.3 newtons at an angle of 0.87 radians and stands at the 3-point line, extending his arms 0.5 meters to accelerate the ball and releases at 2.2 meters, he will always get a swish.